Okay, Assalamualaikum warahmatullahi wabarakatuh. This is quick notes for subtopic 2.6 force. Right? So, in this subtopic, what is mean by force? An agent that can change the state of motion of an object. Okay? Force can change shape, direction, displacement and velocity. Okay? Force daya adalah satu ejen yang boleh mengubah keadaan pergerakan sesuatu objek. So, daya boleh mengubah bentuk, shape, direction, velocity and displacement of object. So, based on activity 2.13, okay, aktiviti ni awak boleh tengok dalam buku teks page 64. Alright, so cikgu harap you click the QR code in the textbook. QR code dengan link tu sama seperti dalam buku teks awak. Dekat situ awak boleh nampak dua aktiviti yang dijalankan. Okay, dua video aktiviti yang dijalankan untuk mengkaji hubungan di antara force and acceleration, and then hubungan di antara mass and acceleration. So ada dua aktiviti lah. Okay. So the activity yang pertama to investigate relationship between force and acceleration with a fixed mass. Aktiviti yang kedua to investigate relationship between mass and acceleration at constant force. Right? So cikgu harap awak klik the QR code ataupun the link in the textbook. Same with the link given here. Okay, to watch the video and try to understand the activity carry out in the video. Alright, and try to understand the procedure in the textbook lah. Okay, cikgu simplify daripada buku teks ni, daripada aktiviti yang dijalankan. Alright, we can see that the acceleration of an object depends on applied force and mass of the object. Okay, kalau tengok aktiviti yang pertama, video aktiviti yang pertama, di mana kita dapat acceleration is directly proportional to the applied force when mass of object is fixed. Okay, kita menggunakan, dalam video tu, kita menggunakan elastic string. Okay, one elastic string. Okay, 2 elastic string, 3 elastic string. So, elastic string tu menunjukkan force, daya. Okay, satu getah elastic string getah lah. 2 getah, 3 getah. So, itu adalah daya yang berbeza. So, we manipulate the force and then we get the acceleration. Kalau nampak dekat video tu, kita letak ticker tape kan. So, ticker tape tu, dot tu, we can determine the acceleration. So, the acceleration here adalah responding variable. And then based on the result, based on the data, kita akan dapat graph directly proportional. Acceleration directly proportional to the force. Okay, when the force higher, right, the acceleration, when the force increase, the acceleration increase. Alright, untuk aktiviti yang kedua, okay, aktiviti yang kedua, kalau tengok dalam video tu, dia menggunakan bilangan troli yang berbeza. 1 troli, 2 troli, 3 troli. So, bilangan troli itu indicate the mass. Right? So, mass adalah manipulated variable kita dan responding kita adalah acceleration. Tapi kalau ikutkan mass, kita tak dapat graph directly proportional. Kita dapat inversely proportional. Acceleration inversely proportional to mass when force is constant. Alright? Tapi kita nak dapatkan directly proportional, kita reciprocal the mass. That's why we put 1/m to get the directly proportional graph. Alright, so based on these two relationship, kita tengok graph yang pertama. A is directly proportional to F when M is constant. And then graph yang kedua, A directly proportional to 1/m when F is constant. So by combining the two relationship, okay, kita combinekan dua relationship ni, kita dapat A is directly proportional to F/m. m. Therefore, F is directly proportional to ma. Alright? Okay. So, dekat sini kita dapat formula F, ma. F directly proportional to ma. Lepas ni cikgu explain macam mana kita nak dapatkan F is equal to ma. Normally, kita state F sama dengan ma. Dalam subtopik yang sebelum ni pun cikgu ada terangkan, ada kita buat pengiraan kan tentang F is equal to ma. Tapi sebenarnya daripada aktiviti ni, F is directly proportional to ma. Okay? Bukan F is equal to ma. Belum lagi. F is directly proportional to ma. Okay. So, the relationship between force, mass and acceleration ni, kan kita dapat F is directly proportional to ma. So, A tu adalah acceleration. Okay? If you still remember, the formula for acceleration, V tolak U bahagi dengan T. Okay? So, and then when we expand, you get MV tolak MU bahagi dengan T. MV tolak MU, ingat lagi tak? Ini adalah change of momentum. Change of momentum. Okay? MV, itu adalah formula for momentum. And then, if we have MV, initial momentum, and then final momentum, okay, we can get the change of momentum. And then, if we divide by time, okay, it become rate of change of momentum. Apa-apa kalau kita bahagi dengan masa, itu adalah kadar. Okay? Dia berkadar dengan masa. So, dekat sini, we express the Newton second law of motion. Kita dapat Newton second law of motion. Kalau masih ingat, Newton's first law of motion, apa dia? Inertia. Alright, yang kita belajar sebelum ni. So, Newton's second law of motion state that the rate of change of momentum is directly proportional to the force and acts in the direction of applied force. From the relationship, F is directly proportional to ma. So, kalau kita nak equalkan dia, kita kena letak satu constant. F is equal to Kma, where K is a constant. Okay, sekarang ni kita nak jadikan dia F sama dengan ma. We assume that 1 Newton of force produce an acceleration of 1 ms per 1 meter per second square when applied on a mass of 1 kg. So, kita anggapkan satu Newton daya yang terhasil, okay, apabila satu objek yang berjisim 1 kg bergerak dengan pecutan 1 meter per second square. So, therefore, 1 Newton is equal to K, ini F, Km, 1 kg, A, 1 ms negative 2. So, therefore, we get K is equal to 1. And finally, we get the formula F is equal to ma. We assume K, nilai constant tu adalah 1. Sebab kita anggap 1 Newton, daya yang dikenakan pada objek 1 kg bergerak 1 meter per second square. Alright, so we get this formula. Alright, okay, so let's see the example. A worker pull a load of mass 80 kg along horizontal surface by a force 160 Newton. So we get the force. If the surface is smooth and without any resistance that oppose the motion of the object, okay, kita anggapkan permukaan tu adalah licin. Kita abaikan frictional force, daya geseran, no frictional force. What is the acceleration of the load? So, by using the formula F is equal to ma, okay, substitute the value, alright, and we find A, 2 ms negative 2, right? Just insert the value into the formula and put the final answer with the correct unit. Alright, example 2. A car of mass 1,200 kg move velocity 30 meter per second. When the brakes of the car are applied, the car stops in 5 seconds. So, calculate the average braking force of the car. Daya yang menyebabkan kereta tu berhenti. So, first of all, we calculate acceleration. So by using formula A is equal to V minus U divided by T. So final velocity here is 0 because the car stopped. Okay. So final velocity dia kosong lah, dia berhenti. Initial minus initial 30 meter per second. And then you get the acceleration of a car negative 6 ms negative 2. Make sense lah negatif. Kenapa? Decelerate. Sebab dia pecutan dia berkurang. Sebab dia berhenti. So we want to calculate the braking force. By using the formula F is equal to ma. So substitute mass 1200 kg. Acceleration you get negative 6. So your answer negative 7,200 Newton. So the negative sign here shows that the force acts in opposite direction of the motion of the car. So make sense lah. Okay, sebab dia brake kan. So daya yang untuk menghalang pergerakan asal kereta tersebut. So negative. Alright. So your answer should be in the right unit. So force kan, whatever braking force, frictional force, asalkan dia force, unit dia adalah Newton. Alright? Okay. So, as usual, to enhance your understanding, please do formative practice 2.6. Question 1. A force acts on a body mass 5 kg. So, if the body accelerates uniformly from 2 meter per second to 8 meter per second, determine the value of F. Right? Try to answer and we will discuss later. Okay, next B, force given 10 Newton. Determine displacement of the body 6 seconds after. Alright? So this is question number 1. You have to answer A, B. And then question number 2. A force of 80 Newton acts on a stationary object 7 seconds and causes object to reach velocity 35 meter per second. So you have to calculate the mass of the object and the displacement of the object. Okay, the question, you can get the question in the textbook. Same question here. Soalan yang sama cikgu ambil daripada textbook. Formative practice. 2 question. Please try. Okay, and then we will discuss later. Alright, so that's all for subtopic 2.6 force. Thank you for watching and please refer me, ask me any question for further information. That's all for today. Thank you class. Assalamualaikum.